great because first speaker is supposed to be on in 10 minutes. And
Yeah, if things are breaking, we'd rather find out now.
yeah. Also, if you wouldn't mind just talking while you're up there, I can see.
Sure.
Oh, you can hear it.
Okay. Yeah, I can hear myself in the speakers.
Yeah.
Maybe, maybe even a little hot. Yeah.
I'm not worried about the room speakers. I'm worried about
Online.
the regular ones, regular speakers. Like stream speakers. You say something?
Something.
Perfect.
Yeah, I'm a bit of a smart aleck.
That's totally okay.
We have fun at work. Let me get a power supply going. So we had a power strip up here somewhere? Oh, right there. I see it.
Yes.
Thank you.
Yep. And then this is the HDMI to plug in.
Yep.
And if you need an adapter,
No, it's
they don't-
HDMI I have. It's in the back.
they don't have any. Oh, here's the adapter.
Yeah.
I'll just get this ready in case somebody else needs this.
Oh, the dongle.
The dongle.
Both speakers first, and yeah, we're on the meeting. Maybe I'll join the meeting.
Okay.
But that way, keep talking.
Yep. All right. Let us connect to the Wi-Fi. Is it Qualcomm Hall? Yes. HDMI.
So that's good.
Okay. And I know you sent me this. Where is
Oh,
it?
it should be in a Google Calendar invite. You want me to? I can get you this thing.
Thank you. There it is. Updated. Hello.
Hey, and then so the key thing is we need your audio to come out of here and into the HDMI.
Okay. So
and it should also go to that should also go to the room speakers. So output device, not Tiger, whatever, but this. Yeah. And then you can test it if you want to, and then it should. That's pretty quiet.
yeah. I can try it on my end too. It might just be low here. I put it up a little. That's better?
All right.
Okay, is there anything else I need to do?
Can Elon hear you?
Ilan, can you hear me?
Yes, can everyone hear me?
Yes.
So just be quiet for a little while. We're going to do intros in like 2 or 3 minutes, and then you'll go on in like 10 minutes. Is that okay?
Yeah, that's okay.
All right, great. And then basically whatever you say, there's people in this room, and maybe we can just show you this real quick. But you want to turn the laptop? I don't know. It's dicey to turn the laptop
Yeah,
around.
'cause
There's like
They're
20
back
people
there.
in the room, and there's going to be more. Some of them are outside of the room eating pizza, and then they can hear you. You're broadcasting to speakers in the room, but you won't be able to hear them, I guess. Not too well.
Yeah, okay, but I'll share my screen.
Yeah, and when you share your screen, it'll show up. Why is this not up here? This is,
I'm not sure. It's showing up there.
oh, projector turned off.
Okay. Yeah, that happens.
Yeah.
Turning on.
I can go for about 15 minutes, but
Perfect.
I also want to see if there's a question or specific things people want to know.
I'll pass you the questions via chat. Okay. Okay, so this is good. Your second screen is on here. Do you want to either mirror screens or, well, or you could put this screen over there, whatever you want to do.
Let's see here.
I'll let you figure that out. I'm going to go get people from outside the room and tell them
Oops, that's not what I wanted to do. I closed the meeting by mistake. So let me log back in. It's because I can't see what I'm doing. So I think I'll just mirror the screens. It's probably easier. Allow. No. All right, hiccup on my end. I'm sorting this out. Settings. Yeah, that's all correct. Excellent. Display. Excellent. All right, we'll start with intros in a few minutes, okay? You'll see a blank screen for a minute. Sure. Ilan, would you mind sharing your screen with like the first piece of material you're going to present and just leave it there? We want to make sure that it's coming through okay.
First, put share my entire screen.
Yeah. That's my meeting notes, as well as my speaker notes, if I speak to them. So the sharing should just come up.
Yep.
Yeah.
It's coming up right now.
Booted
No.
out of the meeting somehow.
It may be permissions related because sometimes you have to do that. On his end, I mean. Yeah. Because I know with a lot of applications on a Mac, you have to set the settings and it requires a restart of the application. Well, welcome back.
Testing this now.
Yep.
Problem here. Okay. Can you see my screen?
No, I still see you.
Oh. Meet needs permission to
share screen.
I think that's just browser.
Yeah, that should be in your local environment somewhere. Mm-hmm.
Let's see here. Settings. Screen sharing.
Welcome back.
Well, we can get started with introductions and then hopefully we can get these sorted out.
Okay. The podium is yours then, sir.
Elon, I'm going to let you get the permission sorted out, and I'm going to do introductions while you get everything sorted out. And then we'll switch over to you when we're done with introductions, and hopefully everything's working. Sometimes you need to restart the browser in order to get the...
Yeah, that's why I keep going away because I have to.
Well, good luck. I'm gonna do the meeting introductions, and because you're our first speaker, so as soon as you get
Yeah.
everything working, perfect.
Okay.
All right. Well, hello everybody. We're still doing San Diego Python, and you're in the right place. There's about 25 people in the room, Elon. And thanks to Qualcomm for having us, and specifically the engineering development team, and Urivan and Drew specifically for like letting people in through the door and being here and all that kind of stuff. So that's been awesome. We are actively looking for a pizza sponsor. So if your company wants to sponsor pizza for San Diego Python, let me know. I would love to talk to you. A couple other small announcements. There's a Saturday virtual meetup for San Diego Python. It meets on Discord. It's at 10 a.m. And so if you go to the San Diego Python website, sandiegopython.org, you join the Discord. It meets virtually 10 a.m. on Saturdays. It's a little different than this meetup. This meetup has a speaker lineup and all that kind of a thing. The Saturday meetup is a little more bring your own questions, bring your own project, that kind of a thing. So a little different. A couple other announcements. I talked about the website, sandiegopython.org. The meetup is streamed to YouTube, so it'll appear on youtube.com/@sandiegopython. They appear under the live tab if you're confused about that. But you can always go back and look at like a past meetup or anything like that. If you remember a talk, if you remember the date the talk happened, you can always go back, or you can click on a couple of them and do that. They always have timestamps, or they will tomorrow. They'll all have timestamps, so you could skip through to the talk that you're particularly interested in. The San Diego Python website has a link to the Discord where you can join for the Saturday meetup, but there's other stuff on there too. There's a jobs channel. There's also some topic channels like web dev, machine learning, that kind of a thing. If your company's hiring, the jobs channel is a great place. You could announce your job to 25 people here, but over the course of a month or so, like hundreds of people are going to look at the jobs channel. Likewise, if you're looking for a job, the jobs channel is good for the opposite reason. Couple upcoming conferences I just wanted to highlight. Pi Beach is September 27th. It's in Santa Monica, one track, full day. They're kind of rebooting this conference. I think it launched during COVID, right before COVID. It was 2025, late February. And so if you can go to that one, they're trying to get this conference going again. If you can help out, if you're a San Diego Python organizer or you are thinking about organizing for something and you want to help out the Pi Beach folks, they can use it. So, you know, they're definitely looking for organizers. I think there's just 2 core organizers trying to launch, you know, a couple 100-person conference, which is an uphill battle. Awesome. I do have a giveaway for tonight, and the giveaway is a 12-month pro license for PyCharm, and we're going to do it whoever asks the best question during Hobson's talk, and Hobson will decide who wins. Yep, that's how we're doing it. No collusion at all, I promise you. At the end of 12 months, basically, you know, if you don't pay them, you get downgraded to the free license, but you don't lose your data or your projects or anything like that. You're downgraded to the free one if you don't pay the money at the end of 12 months. But it's free for 12 months, so you can check out PyCharm and get all the paid features and see if you like them. And awesome. And the most important announcement of the entire meetup: you can become a speaker at the meetup. On the San Diego Python website, there is a Become a Speaker button. Please click the button. Become a speaker. I'm always looking for speakers. When we don't get enough speakers, I'm the speaker. And so I might be the speaker tonight, time permitting. So we'll see how that goes. Awesome. And that is all my announcements. Ilan, how's the HDMI looking? Are you able?
I think it's working now. I think I was just able to share my screen.
Well, why don't you try sharing it? Because I can't. Oh, hey, it is coming up. Yes, that is working.
Okay.
All right. So what I'm going to do, I'm going to go back to sit at where I control the live stream, and I will switch it over to HDMI. And give me 30 seconds, because I also have to switch the audio to come out of the HDMI instead of picking up the audio from the room. So give me about 30 seconds, and then go ahead, get your talk lined up and everything, because right now all I see is the infinite screen of the meet. All right.
Okay. And my talk is basically terminal. So is it ready now, David?
Yeah, you should be good. Go ahead.
Okay. So thank you, David, for letting me present here at the San Diego Python meetup. My presentation. My name is Ilan Schnell. I started my career in software engineering in 2008 at Enthought in Austin, Texas. Is also where I'm still living. Later I went on to Continuum Analytics, and which then became Anaconda, a few other startups. And also in 2008, I created bitarray. If you look here at the change log, in May 2008, I made bitarray first public, and I'm still, after 17 years, actively working on it. The last release just happened 3 days ago, and yeah. So what is this bitarray library? I noticed back in 2008, I was just learning Python. Well, I knew Python pretty well already, but I wanted to learn more about the internals of Python. So I started looking at C extensions, and I found a great C extension in the standard library called array, the array module. And I noticed that the array module supports like characters and integers and floats, but not Boolean not Boolean values. And first, I thought about extending array to support Booleans, but that turned out to be rather complicated. So I created my own project, bitarray, and yeah, that was, I mean, it was written and it's still a C extension. It's very fast. Let me show what you can do with it. I will just import bit array. So I can say A is a bit array, something like this. And well, I can like slice it, take every second element. I can reverse the order. All the slicing works, slice assignment works, and yeah, I can count bits. I can look at the length, and each bit array object has a number of methods. You can import buffers from other objects. It supports the buffer protocol, and you can also export a bit array buffer to another object. Yeah, almost. I mean, the basic object is all written in C, and in 2019, when I didn't have a job, I decided to start writing a utility module for bit array. From bit array util, and that has many useful functions, and I would like to mention two of these functions today, rather functionalities. So SC encode is one of them. SC encode allows you to take a very large bit array and compress it. SC stands for sparse compression. So let's say I have a bit array with 10 to the 24 elements. 2 to the 24, not 10 to the 24. And now I can say SC encode A, and it just returns these few bytes. And the way this works is I can actually show, well, I mean, compressing an empty bit array, the count here is 0. This is all zeros. That's maybe not so interesting, but let me put some ones here into the bit array. And now I can compress it, and now this short binary blob is a little longer. And now I can also import the decode functionality. And now this is my blob. And now I can say SC decode this blob. yeah, and now it's decoded, and A equals C, and yeah, let me maybe show you in the documentation sparse compression. I wrote some documentation about this sparse compression, and the way this works is by instead of storing raw bits, it stores positions of indices, and it uses either 1, 2, 3, or 4 bytes to store those positions. And yeah, it's very fast depending on how sparse your bit arrays are. And here is something, a table I did. So I reduce in each step here, this table, I reduce the number of 1 bits by a half. And so first, first it just uses raw bytes, and then it uses when the density is below roughly 10%, then it starts using these 1 byte per index blocks, type 1 blocks, I call these. And then later it uses type 2, 3, and 4 blocks. But like you can see here in this example, when the probability of having 1 is about 0.4%, it uses a mixture of 1 and 2 bytes per index. So this is actually also written in C, and it's very fast. And yeah, recently some student who was working with fiber optical signals asked me to give him more background information about this feature. And yeah, I wrote more information here. It's all in the documentation. It's actually very easy to find bit array online. If you Google for bit array, it's like the first thing that pops up. And yeah, here's the home page. You go to the documentation, sparse compression, and yeah, here's more information about this. And the other more interesting function that I've been working on recently is creating random bit arrays with varying probability for each byte, for each bit to be 0 or 1. Random P. And if we look at random P, the doc string, it says, yeah, it's equivalent actually to this expression here, where you just have a generator and it calls the random function, which returns floating point numbers between 0 and 1, and it checks if it's smaller than P, and then it makes a 1 in that place. But this is actually quite slow. And I realized about a month ago that there's a much faster way to do this. First, you can take you can take like random bytes and do bitwise operations, like using two bitwise operations, and you AND them together, you can get a bit array with probability of a quarter for each bit. So, and the OR operation, you would get 3/4. And then if you combine the OR, the 3/4 with an AND of another independent random bit array, you get 3/8, and so on. So you can you have a sequence of these and or operations, and then at the end you can actually, what I'm doing is to get to the exact probability, and this is also described in this document here. At the end, I do a final AND, bitwise AND or operation with a small bit array which has exactly the requested, like the missing the missing probability to get to what you want. And that is created by setting individual bits, which is going to be much faster for very small probabilities. So, yeah, 1,000 bits, and now I can like increase the probability, 99, and so on, 0.00. Well, this is going to be, well, there's actually one, yeah, two ones here. On average, you would expect one. Yeah, and that is statistically tested, and yeah, it's like a neat little thing that I thought about, which is now in the library. So, well, that basically concludes my presentation. I wonder if there's any questions from the audience. Oh, well, the buffer protocol, it has many interesting use cases. One of them is actually memory mapping a file on disk. There's an example that shows you how to do that. Let me hear, and did I? Yeah, no. From, if I just say import the bit array, and now I can give it this buffer argument. So this is a read-only buffer. I'll stop sharing again. So this would be like a read-only buffer, but you can also open like a read-write buffer, and yeah, then you can treat any Python object that exposes its buffer like the arrays, but also like the byte array object. Uh, Anything you can then, without copying, import the buffer, change bits, and just treat it like a native bit array without any overhead. And you can memory map files. There's examples for that. Oh, okay. Glad to. Yeah, you're very welcome. Oh, yeah, I'll stay on here. Okay. Well, I can mute myself. Okay. Thanks again, David. Oh, okay. Yeah. Okay. Thank you. Thanks.
All right. Thank you, Elon. That was awesome. I love that talk, and I mean, as a user of bitarray myself, like it's been great. Awesome. Our next speaker is Juan Hernandez, who's going to give us an intro to APIs with Fast API. Juan, you are going to be next, right? Yeah. Okay. And then I will get this laptop out of the way so you have space for stuff. Somehow, I will make this work. I probably have to unplug the HDMI. Okay. Actually, Elon, if it's okay, maybe I'll switch you to the live stream. Is that okay if you just switch to the live stream? Okay. I'll send it to you. If you don't have it, I'll send it to you via email. All right. Okay. And then, should I just shut this for now?
You can close that.
Okay.
Yeah, it hibernates properly.
Okay. And then maybe I'll, yeah, okay. I'll just do that. And then put it here. And
That
then
works.
I will send, and then this is yours?
That is my mouse.
Okay, I'll just set this right here. And then we get one set up. One, do you need help here? One more step. Yep. I'll walk over to the podium. I got that. Yep. All right. You're good. Podium will be on your left here. Okay. There's a bag. That's the podium. Yep. And then that's a, yeah. So it's higher. Yep. There. Yep. And then, yeah. And then there's an HDMI plug. You have HDMI? No.
On this side.
You guys? Okay.
One of the sides.
All right. Great. All right. Well, the HDMI should be plugged in. Hopefully, things just work. But you know,
Just
you
do
never
it.
It does work.
Yeah.
it's working.
Yeah.
It's a nice test case.
Let me see if I can fix that.
Don't worry, that's not coming out over the live stream. So
Good.
people in
Okay.
the room hear it, but nobody else hears it. I mean, I guess it does on this thing.
There we go. Okay.
Your power drink fell off.
Oh,
so
I'll
we'll
take
give
that.
that to you, and
Thank
you can put
you.
it wherever you.
All right, and then so everything is coming out of the HDMI properly and everything. So
Okay.
yeah, and it looks like you're on mirrored displays already. So yeah, you just need to launch whatever you're using
Alright.
to present things. Are you good?
Yes.
All right. Switch over to this one. You're on the title screen.
Okay. So, as David said, my name is Juan. As all you probably have seen, I am completely blind. And as you probably heard, that's how I use my computer. But I won't frighten you with the voice for this entire presentation. Maybe some other time. Hobson's used to it, right, Hobson? So I was going to do this presentation on, I'm going to do a series of these. I'm going to start with an introduction to a little bit of what RESTful is and how to implement REST APIs with Python's Fast API. So REST is a technology. It's a internet architecture used on the internet to, when you hear people talking about an API, that's one of the architectures is built upon REST. And so, like when you have a website and you reach out to log in or get other data, more time than not, it will be on a REST API. So a REST API is stateless. So what that means is there's no when you're connected, you don't maintain. It doesn't. Sorry. When you're connecting to these services, they're asynchronous, and so they don't. It doesn't matter. They can handle a lot of connections, and so REST is broken up into four basic methods. There are others, but for this presentation, I'm just going to talk about the four. Wrong screen. Give me a sec. Okay, yeah. So there's get, which is getting data from the internet. It's equivalent to a database's select statement. And then there's post, that's creating data. That's equivalent to a database's insert statement. There's put, which is updating information. That's equivalent to a database's SQL, and these are SQL database statements that I'm using. Equivalent to update, and delete is delete. There are a few others that we'll talk about in future presentations. For this one, this is all we need. And these are the different methods that we use to interact with the API. So Fast API. To get started, Fast API is a Python package. You need to have at minimum Python 3.7. As of this presentation, we're at 3.13.5. So anybody on that should be just fine. This slide shows basically how to get it set up. So have Python installed, pip install Fast API. You can do pip install Fast API, or what I usually do is to get started is Fast API bracket standard. What the standard does, it also installs all the other packages, basic packages like UVcorn, which is the kind of a server that Fast API runs on for development. Note, do not in production environments, do not use Fast API with UVcorn. Use something like GuviCorn or some of the other ASGIs. And so on here is the different statements to create your environment, install Fast API standard, and then how to activate the environment. Okay. So this is just a basic, very, very basic Python code just to get the basic Fast API setup. It's from Fast API, import Fast API. And then every Fast API object gets started from the initializing the Fast API class. We usually call that app. And so that's kind of important, and I'll show you guys in a minute why that's important. The magic is done in how you set up your paths for the different methods. And so Fast API provides Python decorators. So you can see on this basically it's app.get. And so there'll be .post, .put, .delete based on the type of method that you want to implement. And so you decorate the below method. Oh, and you provide the path in terms of .get. So this one is just slash. So that's just like your website.com / the root of your website. You can, you can change this in any way. You /login, and I have an example that I'm going to show in the live demo. And so Fast API is asynchronous. And so what that means is it allows, basically, it doesn't lock the system to wait for the data to come back and forth. And so this is just a basic root. Just is going to return hello world as a JSON object. So it's a really easy way to implement basic APIs. So I'll do a live demo. That's a little terrifying. All right. So I wrote this code this morning. I did test it, so it does work. So we have here. So here we have from Fast API import Fast API, form. So of course, Fast API is the initial class. That's where everything, you got to start there. You can't do anything without that. And form allows us to accept form parameters from a web form. And so we have here our app equals Fast API. That's initializing our Fast API object. And here's our decorator for a root. And this one will just do a return a hello world. And then I built a login endpoint to show how you could quickly develop like a login interface. So this is gonna, from a form, is gonna take in a post and an email and password. As you can see here, I just hard-coded an email and password. All right, I'm gonna launch the terminal. All right. Okay. So we're gonna activate our environment. And of course.
It's not too much trouble, would it be possible to increase the font size? If it's too much trouble.
How do I do that?
Yeah, normally, yeah.
Okay, Control-Shift+.
Oh, but you're all the way down now.
Unfortunately, you switched to the.
Yeah, give me just a second.
Sorry.
No. Give me just a second.
If it doesn't work, it doesn't work. It's mostly.
Yeah.
You're in a terminal now.
Yeah, and for some reason didn't want to run inside that. That's what I get for trying to do a live demo.
Now you can do Control-Shift+ and it'll
Yeah.
increase your font if you want.
Okay, Control-Shift.
Maybe not. Never mind. It's Windows.
Yeah.
Don't worry about it.
But did that make it any bigger? I maximized it.
It's full screen. Don't worry about it. It's
Okay.
fine.
I forgot for next time. Okay. Period V. Okay. All right. We got our environment. Python. So we're gonna do. So I'm gonna start the HTTP server. So we're gonna go UV corn, and so this is where it's important to make sure you know what your root app object is called. So we're going to do main. Oh man, make sure I'm in the right path. PWD. Yeah, would have not worked. There we go. Okay, now we can. UVI corn main : so main, that means the Python file that you are starting in, and then app is the name of the object that it's going to call. And then I'm just going to do reload. What this is what's really cool about this platform is when you set it up to reload, you can get your server running. Give me a second, I forgot to get something on my Just give me a second. Okay. UVICORN main ABG dash. Sorry, I don't know why it's giving me fits. Close that. Alright, let's try that. Okay. Let's see if this works. All right. We got an application started complete. Phew. Okay, so this is the development interface for Fast API. It's the server called UVCorn. This essentially, what the reload option does is as you make live edits to the code, you know, like if you just make a change in the Python, it will, in real time, once you hit save, it'll reload it. So it allows you to make changes and trial your code. So I'm going to load the form that I created. Login HTML. Okay. I want. Okay. Can you guys see that form? Yeah. Okay. So this took me like 2 minutes to code. So to show you how. So this is creating a authentication endpoint. So I'm going to type in test@.com and just type some garbage in the password, and so I didn't make the return pretty, but see it says invalid email password. Okay, so that means didn't get into the website. So if I change it, if I do me@.com, do test 1, 2, 3, 4, and login successful. So if you had a website that was more, you know, fleshed out, this could have then entered a session, opened a session, and start, you know, allowed the user to access, you know, the various, you know, whatever's on your website. It was just that simple. So all that magic is done with these two, with the. Let me get out of that. So all that magic was just done with one import, initializing the app, and then setting up that this app.post method. And so like up here, I created just the root one. And so if I go to my web browser, so localhost 8000. If I get rid of this, and I return, I get my hello world. So it allows you, because it's Python based, and so you can, you know, return the dictionary, which is essentially, you know, it can be a JSON object. And so that's what allows you to create the, you know, whatever data you want to move back and forth on a website or on a platform. I actually use this to develop WebSockets for work. And, you know, I can get a fully fleshed out API in a couple hours to a few days, where something like this would have taken me weeks or months. One very cool thing about Fast API is this little magic that it does. So if I go to localhost :8000 /docs, I get a Swagger API documentation that's already been done for your own API. So you can hear, here's get/root. That's the hello world endpoint that we just tried. And then here's post/login. So if you're used to using Swagger for documentation, this is already done. I don't have to do anything with this, and so it makes it really useful when working with other people as you build up your endpoints. It gives you a way for them to test it, so they can build in whatever they want to connect to. So, in the future, I'm going to get more advanced with Fast API and talk about sessions and some of the other really cool stuff that you can do with it for future presentations. Any questions?
I don't think there are.
Okay.
There's one question. Go ahead. I have a couple.
Yeah.
One thing I noticed is you're using the unicorn command line.
Yes.
I noticed, I think it was a couple months ago, or sometime recently, I came across it. You can do Fast API dev.
Yes.
And I think they built in that same web server as part of the Fast API pip install.
Yeah. So Fast API dev. So that comes with, if you pip install Fast API, you don't get that functionality. You only get that functionality if you do pip install Fast API standard. And so depending on the installation that you're working with, it might not have that, on that computer.
Yeah.
So so that's why I showed the UVcorn, because UVcorn is pretty universal. And I actually prefer it to running it Fast API dev. I've had some issues with the reloading aspects. The reload feature always works perfectly with UVcorn versus the Fast API dev. It sometimes doesn't reload when I make changes to the code in live.
Yeah, the past 6 months, we're split now. We're using Unicorn and we're using Fast API run for when we're deploying it.
Yeah.
CPI dev for local.
Yeah.
I haven't run into that issue. I just liked it because I didn't need a separate installation of Unicorn.
Well, believe it or not, it is UVcorn. When you run Fast API dev, that's running a form of UVcorn in the background. Huh?
They bundled it in.
Yeah, they bundled it. Yeah. Because to get the so essentially Fast API dev, to get that they had to install the standard package. When you do pip install Fast API square bracket standard, and so that installs UVcorn as well as the Fast API command line commands.
And one other thing, you mentioned it's asynchronous. One thing I've observed is, I think because it is asynchronous, if I want to handle multiple requests at the same time, I've been playing around with web concurrency.
Yeah.
And that environment variable. Do you recommend just scaling out the instances versus messing with those environment variables? Or do you mess with the environment variables? Because I just said it before, and I know it gets scaled on containers or.
Yeah. So we're running. We've run up to a few 100 million connections with this, I've never used the environment. I use the container scale up.
You just scale it up horizontally?
Yeah.
Okay.
Yeah.
That makes sense. I wasn't sure what the pros and cons are beyond maybe some additional overhead.
Yeah. It's got really, when it first came out, it had some serious issues with the overhead, but they've really done a lot to optimize it. And Python 3.14 is going to give it a 30% boost overnight. So it'll be interesting to see what that does when that comes out.
Thank you.
Yep. Cool.
Any other questions? There wasn't any on the chat. All right.
Cool.
I think that's it.
So yeah, that's the HDMI. You can just unplug it.
I'll be right back.
You do a lot of presentations, Juan?
No, not really.
Well, you survived one.
You survived.
I mean,
Where was your last one? You're really good at it.
well, I mean, I do them for work. But, you know.
Those count.
Don't worry about that. That's just a laptop. Back you back to your seats. So you have audio of what the screen shows coming in through your
Yeah,
Mac.
every little aspect on the screen through keyboard commands that I pass it through, and this is just a number pad, but it allows me to give it some extended keyboard control to the software that makes my computer talk.
Got you. Okay. That was awesome.
Thanks.
It's also really interesting to just see how your development process is. Like, how would that work? Right. Yeah,
so-
you're good.
Okay.
I'll walk you back.
Thanks.
Yep. All right.
For your elbow.
Okay. I'll just introduce you, Hobson, and then hopefully everything just works. No, you good. You can stand there. I mean, it hasn't come up yet.
Am I plugging in the right place?
Oh, no, you're not plugged in at all. This thing's dead. You need to plug this in, and we need to plug it in through this thing.
Got it.
All right. And hopefully, this just works. Our third speaker is Hobson Lane, who's going to talk to us about tips and tricks for better, faster, cheaper coding. Did I get that right?
Perfect.
All right. And then, hey, it came up there. So that means
Yeah, we're
gonna
good.
See, what you see there is what's up here.
I got it.
Okay. I'll let you take it away.
Sweet. Finally have speaker notes working for me. So maybe I won't be quite as disorganized as I normally am. Okay. So before we get started, anybody know what FBC is? Well, don't feel bad. Neither did ChatGPT. Acronyms are notoriously hard, especially for LLMs who know everything. But FBC can, according to ChatGPT, it gave me a page, two or three pages of text describing all the different things it could be, including full blood count, Facebook, Federal Business Center, and so on. I went ahead and I gave it a little more context. So just like you would have a really hard time coming up with the right answer on this one unless I gave you more context, I decided to push ChatGPT a little bit. And so the first time, obviously the first one it got wrong. The second one it got wrong when I added the word science, added astronomy, and then I added aerospace. And anybody of my age or older might have a chance of getting it by this point. And I figured ChatGPT, since it's been trained on the entire internet, would be old enough to handle it. But I guess it wasn't born, just like most of you, it wasn't born when this acronym was coined, at least in my world. This was invented in 1992 by someone at NASA. Does anybody have any idea what it might have been? No? Still no joy. Well, once I got to that point and I asked it a full sentence question about, the only way I could get the right answer was when I asked it, what does FBC stand for in the context of aerospace engineering and astronomy? Trying to hint at NASA. And it got it at that point, faster, better, cheaper. Sam Goldman, the administrator at NASA, came up with that concept. And of course, they've gotten a lot cheaper and a lot faster now that they've destroyed NASA with the latest administration. Why are LLMs so stupid? The reason why it got the answer correct the last time was because it did a web search. Those previous ones, it thought it knew the answer. Such a short question, it figures, I know everything, so I'm surely I'll know this acronym, and I'll be able to guess it enough times that we'll be able to work it out together with the user without having to spend the resources to do an agentic web search and then do several iterations on that. And so to save money, they don't do a web search unless you really force it to. And so that extra context forced it to do a web search. And so it used basically the same thing that, and if you went to an Ngram viewer, so this is the first tip of the day to make you a faster, better, cheaper coder and writer. Whenever you're trying to figure out the right way to say something or an acronym, or if there is an acronym for something, or any string of words, if you put your question into 5 words or more, you can search all of the books that have ever been printed that have been scanned by Google into the Ngram viewer, and you can find exactly the frequency over time that those 5 words were used. And so, of course, I put FBC in there. And it was indeed popular. It was the only of those definitions that it came up with. This was the only one that had any history of being used in books. So, and I probed it a little deeper, and in fact, one of them was completely made up. And of course, if you did this search on Wikipedia, you get it instantly. It's the top answer. This is the way search used to work before Google started to dumb it up, because in order to distract you away from the target to actual advertisements or paying customers of them, and getting you away from your actual information you're looking for. So second tip, so use Ngram Viewer if you're looking for word usage history, or if you're trying to figure out the right grammatical way to say something. If you want to see actual English text written by actual humans, and how it's used, and choose the most popular way or the most acceptable way, or the whatever. You can do all sorts of advanced filtering with these advanced search tools on Ngram Viewer. You can also do that on Wikipedia. When you're looking for actual words and spellings of words, use a trigram index, or a TF-IDF index, a keyword search, essentially, a full text search. And then I can go into lots of detail about the magic of how that works, even when you do misspellings. And I want to give another plug for a full text search. It's repeatable. It's scienceable. So you can actually refine your search and go back to that same search engine or that same index and get the exact same results, and you can get better and better at it. That's why people got really, really good at Google search, and that's why they had to change it, so that they had to constantly update it so that you couldn't find what you wanted, and instead went where they wanted you to go. It's precise. It gave me an answer that was less than 100 tokens long that I had to read and understand what that acronym meant. It's online in real time, indexing. That means it can be up to date to the second. Google is constantly trolling the web. Any other, I shouldn't be using Google as an example anymore. Tip number 3, use Metager or Mojeek, or even Brave. If you must, you can use Brave. They create their own indexes. They are much more ethical about the kinds of things they'll put in front of your face. And in the case of Metager, you have to pay for it, but it's well worth it. It will give you an actual index of the web on keywords, and you can do these kind of advanced searches that I'm used to from 20 years ago. And you can find what you're looking for much faster. And they're fast and cheap. That's why little nonprofits like Metager can do this stuff. They're O-log-N to run, whereas a transformer is N squared to run on the number of tokens in your query. That's insane. They're burning up the atmosphere to do something worse than what you can do with a conventional algorithm. So get back to computer science and do things right. I'm going to talk about a few more tools. I didn't get through all of these, but I'm going to talk about the first 3 here. work on, Anaconda, and make slides. I got too distracted by LLMs. First one is work on. You've probably never heard of that. Anybody heard of it? There was a virtualenv wrapper that had a command called work on, and I kind of imitated it with my own bash script. I found someone else who did it about the same time it did because they saw the same things and were trying to make it themselves. There's this package called work on in PyPy. It's a Python package, but both the developer of that and myself found that you can't really easily change your environment like CD into new directories with work on. So I created a bash script that does it. And I will put a link in these slides, and they are at nlpia.org for you to get it. But one of the key productivity saps on an engineer or any worker, really, any white-collar worker, is context switching. When you have to rethink the problem again and again and again, every time you're interrupted, it takes about 5 to 10 minutes to get back to the same level of productivity you were before the interruption. And all these distractions you're getting from the search engines or LLMs or all the hallucinations that are distracting you, that's a time suck for you. Use save all in your IDE. Whenever you do have to do a context switch, obviously you want to save all, just like you'd save your video game. Next, you want to do a commit and push before you leave the terminal. Don't let the interruption stop you before your get, commit, get, push. And while you're doing that, you might as well make a 1-word, 2-word commit message that says, fix me. And maybe gives one other word that is fresh on the tip of your tongue about what you're working on at that moment. So you can trigger, that word will trigger in your mind the same thought processes that you were in right at that moment that you were interrupted. So do that really quickly. You can get that. You can do these with hotkeys on most IDEs. You can probably get over to that person or thing that's interrupting you in 10 seconds or less, and still accomplish these big time savers because they'll save you a lot. Save all your files in the IDE again after your commit message, or I'm also suggesting that you add a line to the code. If you're in the editor at the moment when that happens, put a buggy line of code there immediately, like a fix me. Just put the word fix me in there. And that will cause your compiler or your runner to break at that point, so you'll know where you were when you had the problem, when you had the interruption. And then when you come back, using my work on script or however you want to get back to that environment that you're in when you're in that project, you can do a get diff. And you can see that last commit message, and you can see that erroneous line you added before without even running it in case you forget to run it. Or in case you forget to do the get diff, when you run it, it'll block you anyway. And that'll do it. And if you really want to, and this work on script has the ability to put a .work on file in your project, in the root directory of your project, and it will run whatever commands are there, and you can put the get diff there, and that will appear in your terminal when you do a work on and you change to that directory. So another context switch that can be your own doing is just your imagination. You come up with a really good idea for some other project, and this work on script will allow you to switch over to that other project. Like, for instance, while I'm working on this presentation, I will enter the command work on blogs. And this will, looking at this, and this is the very verbose and debug by print sort of output that I have in my bash script, because bash is incredibly hard to debug, but unlike Python. And but do you see any Python output here? Is this all bash, or is there some Python going on somewhere in this output? Can anybody see anything looks like Python? Yes. Good job, Ulysses. How did you notice?
The where it says info.
Yeah.
I can't recall where.
That's the logging package in Python. You're exactly right. Good call. Good eye. So that's coming from my package make slides, MK slides. Tip number 5, I guess we're up to now. Use make slides. You can turn your markdown into slides with one command. And I use that, and those slides will be updating live. You're looking at make slides right now. It creates reveal.js slides from your markdown files. And you can incorporate that into your work on scripts so that every time you start on that presentation or go back to it, the slides pop up in your browser and you're editing them live in your IDE and they're updating immediately when you save them in the browser. And you can then publish, and you can also then push those up to your GitLab repo. And have GitLab pages serve those up as an index. So if you go to nlpia.org, you will see my index. It creates an index file as well of all your past presentations and keeps them all for you. And so your user can browse them, or your audience can browse them after the presentation. And you can go back to them and refresh your memory and switch back to that context of whatever that project was whenever you need to. Tip number 6, linters. Let me see if I've gone through this one right. Yep. Okay, linters. Does anybody notice any linters here that will clean up your code for you? Which one? Let's see, who's not it? Rough and black both will. I wasn't sure that rough would, but I knew that black does. Thank you for clearing that up. Anybody? A show of hands. Whose favorite? We'll start at the top and work our way down. Raise your hand if your favorite is Flake 8. Raise your hand if your favorite is Pep 8. Raise your hand if your favorite is Rough. Raise your hand if your favorite is black. Awesome. I think black is Rust. Rough is Rust. Black is Python? Or? Very cool. Well, it looks like the Python crew prefers Python. My favorite is none of the above. It's an auto linter, like Rough and black, called Anaconda. Not the Anaconda in the Amazon, nor the Anaconda in NumPy or the scientific computing world for package management. This is the Anaconda, and it's a package inside Sublime Text. It turns it into a much more powerful IDE than you can get anywhere else, and Sublime is free. And I much prefer supporting its bottom line than even PyCharm. Though PyCharm is my second most favorable company, I guess, that builds IDEs, and it's pretty powerful and useful, but I don't like the kind of upselling that they do. But anyway, Sublime will let you use it for free for life from version 1 all the way up to now they're at version 4. And this Anaconda linter was created as a plugin by an open source developer. It's completely open source, and it was created on version 2, and it still works with version 4. This guy knows how to write good software. And you want a good software developer, unlike Microsoft, handling the build of your VS Code, of your coding editor. So all you have to do is spend 5 minutes perusing the GitHub repo on VS Code to know that is not a code base I want my code shackled to in any effing way. Next, and it's easy to install in Sublime. Control-Shift-P is your command palette. I think it's similar in VS Code. And this will bring up the command. You type inst, and that will bring up install package. Then you type ANA for Anaconda. That will bring up Anaconda. Hit enter, and you're done. It's configured in a smart way with good settings and good defaults, and it will automatically fix your code for you instantly, not waiting around for some agent to go around and edit and commit and change your code. it will fix it instantly and fast, just like rough and black. And it will do it online, and it will show you as it's happening in a way that's interpretable and understandable without interrupting you and keeping your brain moving forward in your code. I love it. It's saved me hours and hours of work. It will help you with, it'll find unused imports, it will find unused variables, it will find redefined variables or imports, and if you want to, crank it up a little bit and let it do even more stuff. I've got my settings for you as a link in these slides, where you can download my settings and put them in the correct folder inside of Sublime, and you'll be good to go. So just go to nlpa.org, find these slides, and then find this slide, and you'll be able to find my settings if you want to. If you want to push it, once you've played around with Anaconda and you like it, and you want to see how far you can take it to make it even more powerful for you, more productive for you, that's your next step. Now it brings me to the last one I think that I have time for, and this is all I'm going to show you, so you don't have to. You can wake up from your dozing now because it's almost over. Actually, I got one more slide, but make slides, build slides. So I have a folder called slides where all my markdown files and all my images are. You can put your images in subfolders if you want in order to keep them one for each presentation, but you don't have to. And then build will create all that HTML for you in JavaScript, and it has a lot of configuration files to make it pretty. Your own CSS, you can set up whatever themes you like, dark or light. It also creates that index like I mentioned, and if I might be able to figure out how to show you that index page. If you go to nlpa.org, you'll see the index page on the listing of those. And that's what you can see with make slide serve. And of course, because it's static, it's just HTML and JavaScript. It's a static site generator, essentially. You can put it on any of your favorite static site hosts like GitHub, GitLab, or Getia, or Codeberg. One last one. I think I've heard someone mention UV tonight. I'm not sure. Anybody know what it is? Someone else. Someone new. Yes. Drake. A repo installer. Yes, a package installer. It's a package manager. It does a lot more than that. It's like pip plus venv plus, and it's unlike any Python tooling you've ever seen. It imitates NPM in a lot of ways, which has a run command, and you can use that to launch any Python package that has a script in the environment intended for that package. So it's extremely powerful. It maintains a package.lock similar to NPM. And the reason why I discovered it was because I was starting to gobble up my entire hard drive with a lot of Python packages. And because pip will cache them when it downloads them, but then copy them to any of your environments anywhere when you're using VM. UV is a lot smarter about all that. It's written in Rust, of course, so that makes it faster and more efficient. But because it's written by Rust developers who are very conscious of memory and smart development, essentially. Juan is a Rust developer who's I'm always looking to for advice about coding. And where was I? UV. UV creates hard links from the cached version of a package to the files. And if you ever try to do that yourself manually, it's extremely hard if you're trying to do it on like a site packages directory full of files and data and documentation. You have to do it to every single one, and you have to then create the folders of the parents, and you have to only go up to the point of the parent. Anyway, I've tried to create this kind of script myself, and it's extremely hard, but UV has done it well. And it literally takes milliseconds, 1 millisecond in most cases, to install your package. Because can you imagine pip doing anything in less than a millisecond? No. Anyway, use UV for all of your package installs, all of your virtual environment and management. This is how you would change your use of VN, for instance, to create a virtual environment, to using UV. I've added 2 steps into one by adding this and between UV venv, which creates the environment, and it will name it appropriately. It'll name it as the name of your Python as a display name, but it'll put it in the correct folder that everybody uses called .venv. There's 2 files that you should always have. This is another tip 7 or 8 or 9. Use .venv for all of your virtual environments within the folder of the package that you're working on. And because they're hard links, it's not going to take up any more space in your package, and you can easily ignore it and not push it up to your repo. Likewise, put your secrets in .env, which there's a .dotenv package that you can use in Python to import that and do it securely. And that's one of these packages that will quickly be picked up if you accidentally push it to GitHub, and you will instantly get warned and slapped. And those keys will likely be deactivated if the recipient has access to the ability to invalidate those keys. So it'll save your rear a lot if you use the standard places for standard things, especially secrets and virtual environments. Of course, you activate it just like any other virtual environment by sourcing the activate script. This is all of my stuff is in Bash, but and you can do all of this in Windows by installing git bash, git-bash, tip number 10. Don't show you how to do that here. If you install Git, it will do that automatically because Git is so dependent upon the Bash syntax that they really don't want you trying to use it within PowerShell or some other crufty BS like that. That's it. Any questions?
There's a question from chat. It's from Jeremy, who is ineligible to win the PyCharm license. Is FBC splitting into multiple tokens or into one when you pass it to an LLM, I assume? How would it split the same way during training? And does this token splitting consistency contribute to the ambiguity?
Very deep, difficult question. He would definitely win if he had the option to. It's they use byte pair encoding for large language models or any modern transformer-based model. Does anybody know what byte pair encoding is? Okay, byte pair, it's used, let's see how I can lead you to the correct answer Socratically. What are the bytes, do you think? What things in text can be represented by a byte? Yes, Drake? Nope, that's not what I'm looking for. That's not text. What part of text can be represented by a byte? Yes, an ASCII character, of course, 0 to 127 is all you could do with standard ASCII. But that's enough for representing any character in any language that's ever been talked about as a natural language by humans or otherwise. Because you can use multiple bytes together. But byte pair encoding doesn't care. It just treats bytes as bytes. Whether it's a multi-byte character or a single byte character, they're all the same. So byte pair encoding, how would you pair up? Let's say you are only allowed, let's go with 10,000 tokens in your vocabulary. I think it's more like, I think it's pretty close to what they try to limit themselves to in most transformers. By token, I mean any character, word, sequence of characters, part of a word, or a multi-word string. Any string, basically. Any substring. And you need to choose those tokens so that whenever that the ones that occur the most are represented by their own single byte. And so you don't have to split them up. They're your own single token. I kind of given away the answer, but anybody have any idea now what byte pair encoding might do? How might you pair up things recursively to eventually arrive at that optimal splitting of your text into tokens such that they would essentially compress? You only have 10,000 numbers that you're going to transmit to your recipient to choose from, and you're going to send a sequence of these integers rather than sending the actual text. And you want to compress it as much as possible. That's what byte pair encoding was invented for, not for natural language processing, not for understanding text, but for compressing it into the smallest number of bits so that it can be transmitted efficiently. Anybody have any idea how you might do that? What kind of an algorithm you might do? This would be a good coding interview question. Yes, Drake? Recurrent neural network. No. You're getting, what? A Huffman tree, that sounds right. I don't know that it's right, but it sounds right. It's definitely a binary tree. So you're looking at, first you find the most, first you find all of the 10, you start parsing your strings, and you keep going until you've filled up your vocabulary with all 10,000 of the words. Initializing it, you could just initialize it to all the characters that are in there, and that's going to get you to start with. And now, as you keep going, reading more and more text, you're looking for, does that character occur already? Does that pair? Does that match up with a pair of the others that I have? And when it does, you merge them. And you do that again and again and again. You keep merging them until you're only merging the ones that are most popular. And so you're getting only the most popular, longer than one character strings as your tokens. I've totally butchered the actual algorithm, but it's something like that ensures that you end up with all the most popular. And it's just doing that again and again. And so you're re-encoding the text each time you get, anyway, I'm confusing myself now.
It iterates over the text by replacing with the non-context string most common patterns in the character set.
Exactly. So you're ending up with, you build a dictionary just like a Python dictionary with these integers mapped to strings. And those strings you're now using those numbers instead of the strings to encode your text. And this gets back to Jeremy. So Jeremy's question was, how would FBC be split? I don't know. But FBC is so uncommon. You saw it was right down there close to 0 on frequency in all the books ever written in the past 25, 30 years. So it's likely not going to rise to the level of being worthy of appearing in that vocabulary. So FBC almost certainly used the base characters F, B, and C as the tokens. So that would have been optimal for an acronym. And so it might even have some sort of a kludge or hard-coded rule that whenever it's all caps, you try to, and short, 4 or 5 or fewer characters, then you always encode it as the characters rather than as a token. But words like NASA, they might appear as a token together as a word. That gets us into embeddings and how you determine the meaning of a token and the ambiguity. But the ambiguity is not, the ambiguity is inherent in the word, in the acronym. The ambiguity is not in the erroneous way that LLMs process text in order to try to interpret it. But it's actually in the word itself. It's just that, yeah, anyway, I don't think I have any more insightful things to say about that question. Any other good questions? Somebody's got to win. Yes, Drake?
What about using terminal AI for faster, better, cheaper code?
Oh, that's a great idea. I love, that's another one of the tools that I wanted to get to today was Termux. What is your favorite text editor, text-based editor like in the terminal?
I've been using Warp and
Warp and
Cursive.
Cursive.
Those are AI terminals.
Yeah, but I mean, they are inside of some other terminal. I haven't used them, so I don't know if they have their own editors. I'm thinking of things like Emacs or Vim or Nano. Let's take a poll real quickly on popularity. Who likes Emacs? Who likes Vim? And who likes Nano? I'm a Nano fan, personally, because of the interface is standard across most IDEs. It uses the same control characters without having to learn a whole new language of hotkeys. Hotkeys are your friend. Tip number 12, don't mouse around with your mouse. Stick to your fingers on the keyboard as much as possible. Learn those hotkeys. Learn your text editor, however, whatever kind it is. Another question? People are starting to disappear. Cool. I guess you win, Jake. Drake.
I'll get your email. Or I have your email, Drake. I'll get you the thing. All right. Awesome. Do we think we have time for like a 7-minute talk or no? It is actually 7 minutes. I timed it.
Go for it. Yeah, of course.
You think? All right. We'll do it.
You're losing an audience.
I know. That's fine. All right. Oh, yeah. It probably logged me out. Well, we'll see if we can get one more talk and... Yeah. Okay. Hopefully this just works. And I think we just need to launch a PDF and it'll work. The PDF's like 100 kilobytes. So hopefully it just, the magic happens. Thanks, Hobson. That was awesome.
We're not joining a video talk. We're going to Discord, which I have open.
Yeah, there's my
And
talk.
all
Awesome.
yours.
Yeah, I just need to like, somewhere there's a presenter mode in here. Do you know where that is?
In the browser?
Maybe. Do you think there is one?
Don't know.
Automatic zoom.
Yeah, it's not.
Let's
You
click
can
that. Page fit. Hey,
There
look
you
at
go.
that. We have a thing. All right. It's coming up. All right, awesome. I'm going to give a very brief introduction to DuckDB with a little bit of Python. There's only a little bit, sorry, but so it goes. So first of all, what is DuckDB? What would you want it for? What do you use it for? DuckDB it's in process. It's an open source SQL database specifically for analytical workloads. So it's typically faster than a relational database for analytical workloads. Transactional databases are better for transactional workflows. That means any operations that have like a count, a sum, an average, those kinds of things that your reporting team might do, that is good for this. For people familiar with SQL, like things that have a group by clause fall into this category. It's optimized for column-based storage engines, so it can take advantage of that. Another reason why analytical queries are fast, and it has first-party support for Python. So it handles a variety of databases that you might already be using, a variety of formats you might already be using, CSVs, JSON, Parquets. It can connect to an SQLite database. It can connect to a MySQL database. It can connect to a Postgres database. All these kinds of things. It can read just the parts of the files that it needs. It doesn't need to read a whole file in order to run the query that it needs, if it can avoid it. And it can do this even when it's reading a file directly out of cloud storage like S3 or something like that. It's sort of like SQLite in that it's in process, but it is for analytical workloads, whereas SQLite is for transactional workloads. And just to be clear, DuckDB does not replace your existing databases. It's to be used alongside them to make them easier to query, that kind of thing. So it's not a replacement. It does not replace a transactional database at all. For this presentation, I'm going to be using a public data set of Python package index downloads for the DuckDB module itself. So this is just kind of a public data set. And the syntax here with the attach clause and that kind of thing, it's a little funky, but this could essentially work with a file in an S3 bucket, a file on a web server, a local file, any of those kinds of things. And with a little bit of fiddling, you could even make it work with a password permission S3 bucket. So no issues there. And yeah, just to be clear, this query ran against a remote data set. And you know, if you're unfamiliar with SQL, it just counts the downloads of the DuckDB module for the most recent month. So that's kind of what it does. And this kind of a query can run in like just a couple seconds. So usually with analytical queries, you're not super time sensitive. So just a couple seconds to you know, go through millions of records, that's pretty fast for something that has to go out to the cloud. Awesome. Here's another example of a slightly more complex analytical query. In this data set is like download records from PyPI, and one of the fields has the country of the person or the service that's downloading it. The fact that so many of these records are from the US probably means a lot of this is automated, you know, whether the download is happening to a cloud server or something like that. So that's kind of, you know, irrelevant to this, but basically you can write these really more complex queries, and they pretty much just work, even though the data set is, again, remote. Cool. This is where I want to dive into some of the like Swiss Army knife features that I talked a little bit about earlier, where you can kind of connect to multiple data sets or you know, bring things in. In this example, I'm copying from the remote data set to a local file, and I'm copying to a Parquet file, which is like a column optimized file. Parquet is like a file format that's now maintained by the Apache Software Foundation. It's specifically optimized for these kinds of analytical queries. So it'll be faster to write this kind of a query against this kind of a file than against a CSV or a JSON file. But if you want a CSV or a JSON file, that would just be a couple characters different in the query to get that instead. Yeah, and this kind of shows how DuckDB can be used as kind of the glue code in an extract, transform, load ETL pipeline. If that's what you want to do, I want to connect to all these different data sources and bring them all into one data warehouse. Or you could just not do that and just literally join the data sets together to get the query that you want without actually having to bring all the data into one place. So they can still live in their various sources of truth, and you're just bringing in the data that you need when you need it. So that's kind of cool. I wanted to give an example of how you can actually read from multiple files simultaneously. In this kind of previous example, I dumped 1 day's worth of data. And here, I've already dumped 3 days worth of data into just 3 separate Parquet files. And I can just query across all 3 Parquet files with a wildcard. And it'll just, you know, you can run a count against the whole thing. You can run a count and group by day. You could run a where clause across a whole set of files. Any of these things are possible. It's really powerful. But in this case, I have a single query against multiple files. You could even join these files against what's in an SQL database. I'm going to put join in scare quotes, and the scare quotes are warranted. But you know, you can do that. There's this trend in reporting teams, especially at like really big companies, where they just kind of drop a bunch of data into cloud storage buckets in their normal raw format. Is that the 7-minute timer? Oopsies. Anyway, they just kind of drop all the files in their own format, and then you know, people who need those files can either download the specific files or whatever they need to do in order to run the analytical queries that they need. With DuckDB, you can connect to them directly, run the queries that you want, you know, whatever you need to do. You don't even necessarily need to download them. They call these data lakes, but really it's just a fancy way of saying, hey, I dropped a bunch of files in cloud storage. DuckDB allows querying against these data sets in their raw form. You don't have to like transform them or anything like that, assuming it's one of DuckDB's supported formats, of which there are a lot. So that's cool. And again, only the parts of the file that DuckDB needs to read, assuming that like your cloud storage API supports an fseek, essentially. As long as that works, it will only read the parts of the file that it needs. It won't have to download the whole file in order to execute the query, which is really cool. Yeah. And one other thing I just want to mention, because this is pretty much just like reading files, you're never gonna like have one user lock out another user with some sort of very expensive performance query that kind of locks up your database or anything like that. That can definitely happen with relational databases. If somebody writes a very, very expensive query, you're just reading files. It's very hard to like overload S3 with too many reads, right? That's not really a thing. So this is really nice for that, and it works really well. Because I promised some Python, this is my last content slide, the one with the Python on it. I figured I'd show a little bit of how you can do that. I showed kind of the examples directly in like, I launched the DuckDB command line tool, but it works the exact same way as a Python module. So you can just say import DuckDB, write your query, duckdb.sql, pass the query, and it works the same way. I'm not using it here, but it does support the, like if you're used to some of the other database libraries in Python that use the DB API 2 from Python, DuckDB does have a DB API 2 compatible API, but it doesn't like show the output in quite the same way. Yes, Hobson.
How does it return? Is it returning the values rectangle as text or as data frame or what?
When you type it like this, duckdb.sql, it returns it as text. But if you want something that is not text, you use the DB API 2 API, which is exactly like how CyclePG2 or the SQLite library work. You get a connection, you get a query, you get a cursor from the query, you iterate over the result set of the cursor. So it works the exact same way. I'm not using that here, but you can use that. And if you want data, that is how you use it. But in this example, I'm just doing the one that shows you the results, which is this API. Yeah, awesome. I think that's pretty much it. Oh, I guess, yeah, sometimes, I showed you how you can execute it directly in a one-shot from the Python command line, python-c, quote, import duckdb, write your query. And that's kind of cool. And sometimes it's easier than getting all the connectors and all the libraries for all the different databases all set up. But in a big project, you probably have all that because you need it anyway. Anyway, just kind of interesting. I wanted to show some of this. We're using it a lot at work for analytical workloads. It doesn't replace Postgres at all, or at least not for anything transactional. That's pretty much it. I have links to resources. I'll put this presentation, there'll be a link to it in the video. DuckDB homepage, the DuckDB Python module, which is like, you can get them from it's first party, and then the data sets, which are not first party, which I was using in this example. I put a link to that too. Any questions? Yes. Yes. Basically, yeah. So pandas is mostly, so at least originally, and my knowledge of pandas is poor and outdated, pandas exclusively worked in memory. I know that they were working on some other ways to not read everything into memory. DuckDB does not do that. DuckDB works against files or against relational databases. And kind of the whole reason why you have a relational database is it's too big to store in memory. And so it's optimized for that kind of a workflow. However, if you're running like a really expensive query against a CSV, CSVs are not column oriented. So if you want to run an analytical query against that, it will not be as optimized as something else, whether you're using DuckDB or something else. Yeah, you could. Yes, Hobson. Yeah, if you have a data set that fits entirely in memory, DuckDB may or may not be the right fit for you. You can, DuckDB is tunable in terms of how much memory you would like it to use. So like by default, it's tuned for a desktop computer and will use a lot of your available memory, but you can tune it down if you're running it on a server and say, hey, you know, you could use all of the memory, but I would like you to use no more than 1 gigabyte, for example.
The thing I read with expanders was even when complex CPU in total is 3 to 9 it's still typically 30 gigs because that's the way that my data types are native data types.
Yeah.
Basically right off track right there.
I think this is always a problem. Yeah, if you have a data type that doesn't map to a C native data type, it's going to be either something else or probably some pure Python type, which is expensive to yeah, but it would. DuckDB can try to infer your types, but again, part of the problem is the file format that you're using, CSV, is just text, whereas like some other file formats like Parquet, they have types for the various columns. So, you know, you can say, hey, this is, well, I mean, when the file is created, it will be set up, hey, this is an integer, this is something else. And so it can store it more efficiently. A Parquet is not necessarily a smaller file than a CSV, but you can query it for this kind of things more efficiently, usually. But you could use a lot less than even 1 gig if you wanted to, because it won't read the whole thing into memory, probably. There is a whole thing in DuckDB, which I didn't show and have never used myself, to get a data frame directly from a result. But I have never used that because I don't use any of this like stuff. I use DuckDB for connecting databases to databases or databases to Parquets. I have used pandas very few times in my life. Any last thoughts? I don't know if it'll read an Excel file directly. I do not know. I can look that up. Sorry? Yeah. Yeah. All right. I think that's it. I think that's it for the meetup too, because I was the last speaker. So thank you for coming. See you next month. And thanks to our speakers, and thanks to Qualcomm for having us. Yeah. Sign up to be a speaker. All right. That's it.
No, nobody did. I was watching.